No, it's okay. No, I like this. It's good. All right, let's talk about the binomial theory today.
Let me guess, you're going to get another worksheet?
No, I don't have another worksheet for you, okay? But I do.
We actually need to get our notebook this time.
But I do have some busy work for you. Ready? Okay. What I want to do is keep you out of trouble. Off the streets. Homework number 4 is tonight from the book. Sorry, I just didn't update it over there.
Oh, yeah.
Homework 4 tonight. So I'll do the first one for you, but I'd like you to expand a plus b to the 0, 1, 2, 3, 4, and 5 using your algebra skills. I'll do the first one for you. You're welcome. Is this the kind of guy I am? Okay. Yeah, definitely get at least through a plus b cubed. Maybe some of you who are algebraic ninjas will even get through a plus b to the 4th. Okay. How do you do a plus b cubed? I think you know how to do a plus b squared, so do that and then just multiply by a plus b, right? It'll take a little while. Collect like terms, simplify as much as possible, and tell us the result. Compare with your neighbor. See how you guys do. I'll give you, I don't know, 2 or 3 minutes to make your way through these. If you know some kind of like wizard trick to help you with this, try to do it. Try to not use a wizard trick. Get through a plus b cubed with it. Well, I want you to feel it first. You gotta feel it. Come on, you can do a plus b cubed. A bunch of babies, just do it. Would you like to feel it? That's what I mean. I need you to like feel the rule. There is obviously there's like a theorem that we're going to talk about.
Mr. Chase, did I get the 4th one right?
Why does this work? That's your challenge. Just to know a secret method to fully be able to proof, please. And I think part of the proof would be you actually doing it by hand. That's why I always have to.
I did it by hand.
Oh, you did? Okay. What about now? No, I mean actually multiply a plus b times a plus b times a plus b. Like actually do it using algorithms if you didn't know the rule. Right? Like, and then you'll start feeling why it's true. That's why I insist. Even if you know a wizard trick, I want you to know why it's fun. My turn. Just do it by hand. What's that? Wait, what do you get? You didn't simplify through. You just like erase that. All right, I'll put up the next two for you. There you go. You're welcome. Yep.
Mr. Chase, I need to check my neighbors. Right there.
Check with your neighbors. A plus B cubed. Is everyone done with A plus B cubed at least? Did you combine like terms? When you do, did you get that? Most people did not probably get all the way through A plus B to the fourth or A plus B to the fifth, but I'll show you what those are too here. I just wanted to give you a chance at least to do one of those crazy ones by hand, so hopefully everyone got a chance to do A plus B cubed.
I got it.
All right, and then I want you to be honest. If you thought about this trick before someone showed you because you went to like, I don't know, some kind of highfalutin middle school or something, whatever. Then I want you to like, if you're not a raw mind, like I don't want to hear your observation, okay? But I want someone else though, who's a raw mind, who's never thought about this before, to notice some patterns that you might see, whatever they might be. I want low-level observations. I want high-level observations. I want everything. Anybody? Anybody else? No?
Oh, that's
Let's start by noticing the variables. Talk to me about the variables. How about those? For a given row, what's going on with the variables? Cheyenne.
So when it's like A and B, like the powers always add up to
Yeah, great observation. It looks like the two powers on all the A's and B's add up to n, whatever A plus B to the n might be. Right? Do you see that what he's saying is true? Good observation. What else? Any other observations about just the variables, not the coefficients? Any other observations just about the variable? He was saying all the variable powers always add up to 4 in this row, right? Like A cubed and B to the first. That's, the two powers always add up to 4 there. Yeah. Any other observations about the variables? Or no, or what? Yeah, Trey? Yeah, we got like a raw A to the n and a B to the n at both ends with there's some nice symmetry here too, so in that way. Cassie has something to add?
I don't know, so they're like descending is like A to the fourth, A to the third, A to the third, A to the first, and A to the
I think descending is a great word for it. Yeah,
but then the second one's
yeah, we have all the powers of A from A to the n all the way down to A to the 0, accompanying all the powers of B from B to the 0 all the way up to B to the n, in that order, which ensures we have every combination of those two things. Go ahead. All right, so you talk about the coefficients a little bit too here? Yeah. Of A and B? Oh, this first term you mean? This coefficient is always equal to like the power? Yeah, the second coefficient in each row is equal to the power. That's an important observation, I think. Yeah. Let's also start with an even simpler observation. What's the first coefficient? and the last coefficient? 1, right? Let's also say that. Good. Go ahead, Ian.
Since we're talking about the
Coefficients. Yeah, go ahead.
It's Pascal's triangle.
All right.
It's 1 on the first layer, 1 on the second layer on both
Yeah,
ends.
let's highlight it there for you. You see
And
it?
then you have a 1 on either side, and you add up the two numbers above the middle one and two. Of course, I'm pretty sure most people here know what Pascal's triangle is.
Yeah, some of you have seen Pascal's triangle maybe, and it has lots of interesting properties. Maybe a teacher has shown you before.
More interesting is that the powers of the given variable continues on a diagonal from for the A, it's when going down to the right, and for the B, it's when going down to the left.
Yeah, we have lots sorts of interesting numbers in Pascal's triangle and lots of things we can observe.
But I thought the powers.
Yeah, I think you're right. Yeah, I mean, I can think of off the top of my head probably like 30 things that are interesting about Pascal's triangle. But the one I want to hone in on today has to do with like why this is even being taught right now. In fact, you might have had that question, like why? Wait, seems like a departure from things taught yesterday in the report. All right. So let me work with you on this here. If say you're doing a plus b to the fifth and you're expanding that out by hand, how does this actually feel? I want you to understand that that's kind of like superfoil, right? You're like, do you agree that if you were giving instructions to someone to how to do FOIL, instead of saying like do FOIL, you could just be like multiply everything by everything, right? Yep. FOIL's just, right? Isn't just FOIL like a way of ensuring that you get every possible product that you could form? So isn't that what we want to do here too? For example, we want to multiply this A by this A, this B, and that B, for example. That's one of the things we need to do. There are lots of things we need to do. That's one of them, right? We also need to do B times A times A times B times A or something, right? So let's ask first, how many ways are there to form an A to the fifth from doing that? Like how many ways could I choose an A from each of these? Yeah, there's only one way to form the product A to the fifth. It's by picking an A from each set of parentheses, yes? How many ways are there to pick 4 A's and a B? That is, how many? I could pick this A, this A, this A, and this A and choose that B, for example.
You can do that 5 ways.
Can you do it 5 ways, right? By the way, picking 4 A's is the same as picking 1 B, isn't it? Like those two questions are the same question, right? Picking 4 A's is the same question as like how many ways are there to leave 1 B on the table, right? If you're Sophie and Sophia, okay? So I think that coefficient needs to be a 5. Now here it gets interesting. What if you want an A to the third and a B squared? That is, you want to pick 3 A's and 2 B's from among those there. How many ways are there to pick 3 A's from among 5? Why is it 10? What does that come from? Yeah. Isn't that 5 choose 3? All right, this gives way to a larger principle, right? In fact, isn't that what we did here? Isn't that 5 choose 1? In fact, isn't this 5 choose 0, right? Yes? You're ready to hear the binomial theorem. Okay. So when you're expanding a binomial of the form a plus b to the n like we just had, then we get this expansion. Notice everything you just talked about a second ago is true. Yes? You have a to the n all the way down to a to the 0. You have b to the 0, which I'm writing here, but obviously you don't have to. N to the 0, n choose 0 is 1, and b to the 0 is 1. So, right, you understand though. All the way up to b to the n. And the binomial coefficients are the things we've been studying all along here. N choose 0 all the way up through n choose n. Which, by the way, do you notice that in the expansion of a plus b to the n, there are n plus 1 terms? Right there. Hopefully you see that. Something else is for you to notice. What do all the entries in one line of Pascal's triangle add up to? What is n choose 0 plus n choose 1 all the way up to n choose n? K is a stand-in for one of the middle ones along the way, right? The point is, if you're looking for the kth entry in this expansion, it's of this form. Like if you want the coefficient on b to the 6th, a to the whatever n minus 6 is. Oh, I'm just saying there are n plus 1 terms here, aren't there? Right? How many numbers is 0 to n? That's n plus 1 numbers, isn't it? I mean, you understand that in the cubic standard form you get 4 terms, don't you? Yep, something times x cubed plus something times x squared times something plus something plus a constant. All right, let's do a plus b to the 6th, then you'll feel it right away. Let's do it. Let's do this time. I know you could sometimes you could iterate on one row and get the next if you recognize the Pascal's triangle rule. But I'd like you to do it using this method now that we have it, just to practice, and then you'll be able to check whether it makes sense iteratively too from the previous line. So what do? It's a to the 6th, b to the 0, 6 choose 0. So we just got a to the 6th at the front, and at the end we'll have just a b to the 6th. What do we get? A to the 5th, b, and the coefficient there is 6 choose 1. like I said, you could add a 6 to the 0 here if you 6 choose 0 here. So what are these? This is 6 choose, 6 choose, 6 choose, 6 choose, 6 choose, if you want, right? So what do we get here? A to the 6 plus 6 a to the 5th b plus 6 choose 2. We have to think about it. 6 times 5 divided by 2. Is that 15? Right? 6 choose 3. What's that? 6 times 5 times 4 over 3 factorial?
Go 5 times 4.
So that'll be 6 and 3 factorial cancel out. That'll be 5 times 4 is 20. Yeah? And then now we're home free now, right? Because 6 choose 4, we already did 6 choose 2. That's the same, right? We get this nice symmetry happening here. 6 choose 5 is 6 again. How do you like this? Does this look good? Verify using the iterative technique that this does seem like the next line in our triangle too. And to answer someone's question, aren't there 7 things here?
Oh, no.
That's all I meant. Yeah, that's all. And that'll always happen. How about some? Oh, sorry. Now is good. Okay, let's try some slightly more interesting questions here too. All right, so this one's not too bad. Let's give everyone a chance to think about that on their own, and then I feel like these get a little more interesting. So we'll give you a second to do those, and we'll put that together. Yeah, we're just asking, find the coefficient on m to the 3rd in this expansion. Like, what will it be? Just my way of asking this question without actually saying, can you please write out the entire thing? I can make you do that too, but I thought if you can do one of them, I think you could probably do them all is my point. Let's just save time and prove that you can do at least one of them. I know, I asked that going in.
I was trying to.
Good job, Ian. You're smart. That's right, man. I'm pretty sure it's a
Wait, what's the minus 2? The minus 2, right?
Daisy, you want to give us the answer to the first one here? What is that? 15 choose 3. Right. 455. Is that what it is?
That means you have to find. Oh, wait. So, wait, it's 6, right? That means 3. Wait, that means 3, right? That means it's 7.
Why would you ask?
Wait, that means, no, that means negative 2 is the power of 7. So, what means it's 7? It's negative 128, so you subtract 100. Okay. Then you have that, and you multiply that with 200. And minus 2.
There. Do you have class here? What? Do you have class here? I do.
Can I see it? Second one, right? I got A was negative 2,200.
Okay, let's pick up on the second one here. All right, so help me out here. So we got m to the 3rd. I actually, in some ways, having two variables is better in my life, right? Like having the -2 makes my life more troublesome. I have to deal with powers of -2 then, right? Because isn't this m to the third, this term, -2 to the, well, what would that be? Don't those have to add up to 13, yes? Okay. And then we have a binomial coefficient in front as well, don't forget. And that binomial coefficient will be what? 13 choose 3 or 10, whatever, doesn't matter. Good. Now we need to simplify, but in a second I think we'll know what A is. That is the coefficient on m to the third. But notice here that I don't want you to just type in 13 choose 3. I do need you to do that, but you also need to multiply by, what does that come out to be? 1024. So multiply 13 choose 3 by 1024. And then you'll have your coefficient on m to the third, yes? Notice that introduces another piece that we haven't had to think about yet. So what is 13 choose 3 times 24? Say it again. 864. Did someone confirm? M to the third. So apparently A is the thing she just said. 292,864. All right, and then over here we've got something times m to the sixth times -2 to the 7. Okay, so what's the coefficient up front? Well, I mean the binomial coefficient is what? 13 choose 6 or 7, right? Yeah, so notice here that we have to be a little careful, yeah. So 13 choose 6 on your calculator, you're multiplying this time by -2 to the 7th, which is -128. But notice here that the coefficient comes out to be a negative number. So does someone have that at the ready? What is that?
Is it -219,648?
I don't know. Is it 219? Say it again.
-219,648. Is that right?
Can someone else confirm, please?
I may be wrong.
So that's the value of b then. Notice that if you were to do the whole expansion, you'd have every power from m to the 13th down to a constant term with m to the 0, and that the signs would be alternating. Which ones carry a negative sign? Which powers of m?
M has an odd.
Which ones carry the negative sign? Which powers of m?
Even ones.
Yeah,
Even ones carry
the even powers carry a negative sign, like this one here. And all the odd, so it'll be alternating signs as you go, if you haven't thought about that. Right? It has to do with the fact that we're having odd even. Okay, so down here, so I hope you appreciate how this can be tricky. We've got negatives to worry about. We got like numbers that could enter in. All right? Here we've got another little piece to figure out. So we got some binomial coefficient. Well, on the front it'll just be, I'll just skip it, right? So what is that? 3p squared to the 5th times 1 to the 0 plus 5 yeah, just be careful as you resolve this, right? We have 5, what is this? Oops. 5 choose 2. 3p squared, the third, 1 to the 2nd. Someone already have this? You want to do it? Take it away.
Just the final answer.
Yeah, the final answer. Give the whole final answer on that one. Have you learned anything today? It would blow your mind, at least. I don't know. Hopefully, every day you might find something. All right, critique Matt's work here. If he has anything wrong, tell him. Interestingly here, Interestingly here, we get all powers that are what? Yeah, e to the 10th, e to the 8th, all the way, no, so all the even powers there, right? Do you agree with Matt on those answers there? Notice again how we can make, you know, we have interesting powers here, 10, 8, 6, that's an interesting twist to the problem. We have the 3 that's coming in here, we have to keep track of, and we always have the binomial coefficient to worry about. Which, by the way, I think you'll start hearing people, like as you're doing math in higher levels, you'll start hearing people talk about n choose r as being the binomial coefficient. Even when you're not talking about binomials, people will be like, oh, you have the binomial coefficient there? You know, even when we're like not in that context.
No, it's not plus 1, it was plus 1.
It's plus 1, I think.
No, but then plus 1.
I had a few more problems that I thought were fabulous, but you know, I guess we're done.
What are you doing tomorrow?
We could do them tomorrow. I mean, look at that. That's beautiful. That's so much
Put it
better.
on classroom and assign for homework. That's what you can do.
That's a good one, right? That's good.
I will find an expansion calculator on the internet. I hope you know that.
Any good computer algebra system will do it for you. My C99 will do it.
I only did TI-84 do it? I want A plus B for the 97 power.
Secret calculator. We're going to let you use that.
They're not bad.
They're banned from already. On test.
Today's World JV and Varsity Lacrosse Day has been moved to tomorrow morning. Varsity at 9 and JV at 10:30 at RM. Tomorrow, JV baseball and JV softball day have been canceled. Girls varsity lacrosse practice is canceled. Boys tennis practice is canceled. Softball is meeting at 10 and 3. Boys varsity lacrosse will meet at 35 at 3:25. Boys JV lacrosse is meeting at 18. Girls JV lacrosse will meet in room 33 at 3:30.
Firm maybe. What's up, you guys? I did.
Oh, please, Matt.
Lauren's going to be here probably in a second to write a new joke up. Well, I guess have a great weekend, everybody. Yeah, I should try. Now what? Look what you've done now.
Why are you pushing that?
Really important. Oh. Bye guys. Have a good weekend.
I wanted to say thank you.
Did you get in?
Yeah, I want to say thank you for all of your recommendations. I was accepted into Yale and Princeton yesterday.
Oh, is everyone finding out these things? It's just so exciting. So what are you gonna do?
I don't know
Oh,
yet.
that's pretty exciting. That's a tough choice. What are your top choices or something? What are your top choices? What are we gonna do?
I don't know. I don't know. I didn't have a top choice when I was applying, which made it nice because I didn't have too much like emotional investment in one particular school.
That is good. That is
So
good.
it didn't
Math.
crush me
Exactly.
when I didn't get into somewhere, but yeah, I did early decision TDO, so that was it.
So does that mean? But that's not early action. Right?
Yeah, early. It was restrictive early. It was restrictive early.
So that means you have to go there.
No,
No.
it was single choice, so that means like I could only apply there early. That was the only school I could apply to. But then I got deferred, but then I got.
How do they know you have applied to other places early?
Because it's
Honor system?
on the Common App. Like,
Oh, and they know that.
yeah, so
because
if
they
you
can
say
see.
that you're applying early to one school, like that's single action restrictive, then they don't allow you to apply to any of the schools. And even if they like, even if you like hack the system and do it, then that's grounds to like rescind your acceptance. So, alright.
Oh man, you got some big decisions to make here.
Yeah, thank you so much for your
That's awesome.
recommendations.
Congratulations. That's a big day. I bet you're like, whoo.
Yeah, it's kind of crazy.
All right, don't still pay attention to all your classes though, okay?
Yeah. Okay,
Have a
bye.
good weekend. Yeah, all right, everyone had good things to say about your joke today, Lauren.
Wow.
A lot of good feedback. Yeah.
I did like this show.
Yeah, that was good. You got good perception.
Is it too dark?
If you have to ask, it might be. I don't know. What are you gonna say?
Why can't organs program?